So this is the Substation Design Suite first webinar. This is on building toolbars. And the purpose is to show what we can do with the toolbars and go a little bit beyond what we do in training. And I want to remind people, a lot of stuff I'm talking about is here in the help files of the Substation Design Suite website. If we go into these help files, the main files we're talking about today is setting up the content database. This is the main one we're talking. If you right-click, you sign into Substation Design Suite, you right-click on it, and you can do Save As, and you can print that out, take it home and read it, put it under your pillow at night, and study it. The things we're doing here is we're going to use the content editor. We're going to be customizing the database, and we're going to configure the database. So this help file here is part of the training, and this is how we're getting to where we're going. What we will also be doing today is getting into building content for SDS. This is another document that you can take home and read, print it out, and post it beside your computer and read it every day. But this is another one. This is talking about how you want to put work geometry on, what we can do with it a little bit, but it's telling you what geometry we actually need, and we'll give you examples of such. So this is a worthwhile document, and this is the tools we are using, and we're going to combine some of these. We might combine a cable with a tap fitting, and you'll see that later on. What we're also using today is this document here. Oh, sorry, this document. This is an older document, but it's still relative, and this is worthwhile to read too, and it talks about some of what we're doing as well today. So this is another document we are using today. Save it, print it, read it daily. And those are the three main documents we are using today. The content database, building content for Inventor, the work geometry for automation, and of course the database document. So those are the main documents we're using. If you had taken the training, those of you who have, which is quite a few, what we're doing today is just a little bit beyond what we did in the course. When we go down into the course, we go in advanced SDS, and this is where we're getting into doing things here. So really, the help files are here, and they're I think they're quite good, and this is what we're covering today, is how to get a little bit beyond what we did in the training. So the other tool we have that people could reference is, because what we're going to be doing is editing and adding fittings to the database. There is a model, a video on the consortium YouTube website that talks about library fitting preparation, and it will just tell you a little bit of what you can do to help get your models prepared to put into the library. There's just little things, little cosmetic things. Turn the background to white. It talks about compressing the file so the file size is smaller. It might compress it at like 5%, or it might compress it 20%, depending on what that file is. So this is a worthwhile video to watch as well. So let's get into what we're going to be doing. On the screen is my typical demo model, and this is the model we are going to be working with. I have a number of items here. This model is following the substation design strategy that we teach in the training. And what we have lightning protection in its own group. We have the bay in its own group. We have the underground in its own group. And even within that, we have each item, the conduit, ground assembly, and trench, all in its own sub-assemblies. So that's basically part of the substation modeling strategy. And of course, there's a skeleton in each one, and the skeleton, of course, has work planes, and any of you who've taken training will see how that puts together. So this is the model we're going to be using. These are the toolbars that we're going to be customizing. Those who've taken training have seen some of this. I don't know how many people are customizing, but up in the corner here, you can see the different files that we can bring in. All right, so we can put these right into the database. So for those who don't know, this is all customizing what we can do with the database, that we can bring it into our work here. And there's bus fittings as well. And what also people miss is when they come into here, they come into below grade tools, what we also can add is trench parts. So we'll be talking about the trench parts as well coming into here. Further, we can also add some conduit parts as well. So these are the other conduit parts. So these are the 4 or 5 main areas we're going to fiddle with the database. So how do we get some of this stuff in here, and what are we doing? So let's go back to the above grade tools, and we'll look at what we have in here. So if you look in here, I got a couple of terminal fittings. I actually have a piece of Carlon conduit. That's a connection piece. And I have a Ceph core fitting in here. So I don't have all terminal fittings. I have some different things in here. If you look in here on this one, we have it branched out in different categories. And in the bus fittings, we also have different items in here as well. So let's look at that. So when we customize the database, we're going to look at the database here. And this is a little bit of a remedial or whatever, a beginner type of thing right now, just to get people introduced who just don't have quite the introduction right now, and then we'll go further from that. But this is the database I am using. It's 44 megabytes in size. The one that comes with the software is only 25 megabytes in size. So you can see how we add items to the database, and we're going to add to the size of the database. Is it a big problem? No, not really. It only loads when we install, when we open Inventor. That's when the database is put in to memory. So it's only put in once when you start Inventor. So I just want to show that the database does grow when we do this. What we also want to do is, if we customize the database, we want backups. So you can see here with the webinar, I got my first webinar one, I got my second one, and it's the second one we're using today that's been renamed so that SDS can read it presently. So this is what we're fiddling with here. If you read the documents that I showed you before, you'll know where this location is to find it. Read the documents and you'll find this. The other tool we're going to be looking at is the SD content editor. The SD content editor allows us to access the database and manipulate it the way we want to manipulate it. So again, if we can create a shortcut on our desktop, again in that database document I showed earlier, it explains on how to put a shortcut on your desktop to get the content editor working. In here you can see we can add items. When we add items, we can come in here and go select. And one thing that people miss, and I don't talk about it too much in the training, but I do talk about it here. When I do talk about it, we will talk about it here, is the assembly files. We can put in assembly files in here as well. So we're going to look at all kinds of stuff in here and bring it all up. So let's come back into here. We also talked about putting trench and conduit parts in here, and lo and behold, there's a whole page for trench and conduit parts. You can see the one piece I added here, and you can add many more. The other thing is that these are the standard out-of-the-box items above it. So I just added one little coupling. What I've also added were a lot more trench pieces. So I've added trench pieces in here as well, and I put them in here. So all of these files, what they need is work geometry to make it work. And again, that is in the document that I showed earlier. This is the key document for some of what we're doing to get this stuff to work, is to add the work geometry for automation, that we have to put this stuff in. All right, so this is the key document for the work geometry in the parts. So let's go back to the cable fittings and look at what we have. So we're going to think about what are these 3 tools. We got, or 5 tools, and let's go back to our model and we'll look at the five tools themselves. So find in window. So if we look at those 5 tools, we have the terminal fittings. So the terminal fittings are in the top right, and what are they doing? They're places items on a circular edge. So it adds 2 mates, an edge mate and a surface flush. So there's 2 constraints that are added. And that's what we're going to be playing with. And we got to think, well, how can we use it and how it's going to be placed. Bare cable fittings places items on a NEMA hole arrangement and adds 2 insert constraints. This is just to keep us in mind of what the tools are actually doing. The bus fitting places items on a cylindrical surface. It does an axis mate and an origin work plane mate. So if you've used this tool, you see it does an offset, and then you can adjust that offset. If you've gone through the training, this is precisely what we do, is fiddle with that offset. Trench items are placed on a work point mate in a UCS constraint set. So if you used a UCS constraint set, if you come up here into constraints, here's the constraint set. For those who haven't used it, it just puts a UCS to a UCS. So it's a handy tool. I don't think it's the best tool, but it is a handy tool at the right time. Conduit items are placed on a work plane mate and a point mate. So it works on a point mate. So if we look at some of those items in this document here, and we look at what a trench has, and we're talking about a trench is putting on a UCS mate, it's attaching to the UCS ends here when we place it in. When we're talking about the conduit, it's placing on these work point start or work point end so that it has a continuous flow. When we look at the terminal fittings, we can see the work geometry for those, and it keeps going on, and that's what we're using. So those are the key things. So let's go into what we're doing here. So the first thing I want to show is just the basic attachments. So let's come into our bay assembly, and this is what we're going to work in right now. I'm going to open this up, and as you guys know, and probably have done this a number of times, you can come in here, and we can add parts in here. So let's delete that guy, and I think everyone knows, they've gone through the training especially, they know this. I can come up to fittings, I can grab a fitting and put it on there. And then of course I can rotate that fitting and rotate it around. So this is a lot of stuff that people know, or I hope they know. But we're going to go a little bit beyond that. So I'm going to look up here, and what we're going to do is place different fittings. So let's first place what I had suggested earlier was a assembly fitting. So let's look at what we have here. We got a bifurcating piece with some parts to it. I'm sure some of you there will recognize this type of arrangement. So I'm going to come in here. I'm going to open up the low side island, or the high side island. And I'm just going to delete this piece, and I'll put it back in later. And we can delete the cables. We're going to just put all this back in again. All right. So let's identify what we're going to do. We're going to place a assembly fitting, and here I've created an assembly grouping. So let's go back into the database, and you can see with the bare cable fittings, it's only on the bare cable fittings right now, and I hope to see in the next release that this is the same for all of these groups, because there's a ton of information we can put in here. But in the bare cable fittings, there's bolted. I've grouped them as bolted, grouped them as bus, bare cable, crimp, and I put assemblies. And you can see they're not in order, like I don't have them grouped in order, but at least I can put them in, and then the software will put them back in. You look in the background is white for all of these, so it looks really nice. So we're going to put in my assembly here. So let's come in here, come up to the tool, and we're going to add this assembly, and I'm going to put it right there. So let's find this in the browser and see what we're doing here. So there's my assembly. We're going to open the assembly and just understand what we're doing with this assembly. So you can see I have the main bifurcating piece here, and then I have the two fittings here attached to it, but that's not all. If you've taken the course, you'll see that we talk about empty parts. And in here I got bolt, nut, and washers in here. So let's look at the bill of material for this little assembly. So here in the bill of material, we can see that I have two normal parts, and then I have four empty parts. I call these empty parts. All they are is for bills of material purposes. So it just brings in the information there without bringing in the heavy weight of having another part and having all those lines drawn whenever you do a drawing and such as that. Because most of our stuff is viewed from 5 miles away, right? You're got that long range view. Rarely do we come up in a close detail, and when we do, we could do something special for that. Does it have to be this way? No, you could actually put the bolts, nuts, and washers on. Just make sure you have a good network and a good machine. So this is the information we put in here. Now we want that information to pass on, and if you've taken the course, we do talk about phantom assemblies. And of course, this is a phantom assembly. So this allows the children of the parent to show up in the bill of material, but not the parent itself. So the bill of material does not see this assembly, it just sees the children here. So that's what we've had added here. So let's say okay to that. Now we're going to add that piece again here. So now we have the two assemblies we've added here. That's part of the high side now, because that's what we want. If you take the course, you know we want everything populated on the islands as much as we can. This is an island because it's all rigid bus. We want this to move vertically with the slope of the land all together by itself without having to try and change individual pieces, as well as it helps us for levels of detail. So here's our assembly here. Let's find it in the browser. And there's our assembly here, and we can come in and we can see all the parts in there. So we've just added a whole whack of parts with one click. And it's really nice to do when you have 50 or 500 of these assemblies in a large station. Now we want to rotate that because we do have that rotate tool. And if I rotate the item and just pick something, it's not going to rotate correctly. So what we want to do is when we hit rotate for an assembly, and I'm talking about assembly, we want to hit the assembly. And what it's doing, it's going to look for the first item in here, and that's what it's going to base things on. And then it's going to work on these insert constraints. So if I click this guy, what we should get is the rotation that we want to see. All right, so we can rotate it. So I'm going to close that, I can save it. And now I've got my two items. I'm going to check my settings as we always do. I get the right cable. I guess that's the right cable. It looks pretty good. And I'm going to pick fittings to add cables. For those who've seen this before, I'm going to hit P for pair. P for pair. And away we put that in. So it's really nice that we can put in assemblies. What I'm showing you, I can put that assembly in its own group. I could have a whole bunch of assemblies in here. One thing to note, though, all the items that are in this assembly also have to be in the bill of material. All the items in this assembly have to be in the database as well. So when you look in here, I also have in here, it's in the database, sorry, it's in the database here. If you look at it, you can see those items are in here as well. And that way the database sees everything that's coming in here. So if we open this guy again, what we're looking at here, and what reminded me when I looked in here, is that when we come up to bus fittings, if I want to make my own in here, I can add a bolt in here. And this is an empty part, like I said before, and I can add that empty part to that cylinder. And now I've added another bolt, right? So I can do it right out of the tool and create my own little assemblies on the fly, and then maybe put them back in there. Or I could always come in here, browse the fitting. If I made one on the fly and I need to make one, I can grab an assembly out of my fittings. Now, I would recommend you guys always have a fittings folder and keep all your fittings in one folder. I'd go along with that. There's a video for that as well. So what I'm showing is that we can add things directly from there. What you also saw in there is that not only do I have those fittings, but also threw a tap lug in there. So let's look at what the tap lug does. If I want this tap lug, and I'm going to put the tap lug there for some reason, and there it is. It is placed correctly, actually. It just looks like it's kind of sunk in there. But that is the piece that we want in there, and we can do it that way. So it's another way of placing something that's totally not part of what you would think you'd put in, but it's something we can do. Does everybody want to do that? Maybe not, but this is an option we can do. So then I could run cable to that tap. So that's a nice tap to put in, and you can grab any circular point in that, because if you remember what we talked about earlier, is that if we look at what we're doing there, we are with the bus fittings, it's grabbing any cylindrical surface, whether it's an interior cylindrical surface or an exterior cylindrical surface. It's going to put it in there. And then it will give us a mate that we can offset. So if you've done this before, you can offset that mate back and forth. So let's go back into the bay. And if I've put in, let's go into the bus over here. You can see I got a nice T in here that's been placed using the tool. But just to make sure you know that, I can put in a union fitting. I don't really need that break in that union fitting, right? Because really we only want to totalize on the total number of feet of bus. We don't really care if there's a break in there. If you want one, that's another matter. But we can put that fitting in there. If you look at the constraints of that fitting, we can offset where that constraint is, and I can put it to 0 and put it right in the middle, right? And of course, I can also put other things in. As you can see, we have the other Cepcore vibration dampening tool. So this is just a couple things that we can do with that. So it's not just fittings to place in there. Now, earlier we showed that there is a Ceph core end fitting. So let's take the Ceph core end fitting and we can put it here, right? Let's put it at this little end fitting here. All right, so if I put that end fitting on this side, is it going to work the same? So let's open up the high side voltage. Take this guy off, and let's put that end fitting here. It's not really what I want, right? And even if we rotate the item, we're not going to get what we want either, right? I don't want that. But what we can do is throw that fitting over here. And what we're doing again is looking for a circular edge, not a circular cylindrical face, but a circular edge. I can grab that circular edge, and it's going to place it the way I want it. And I might have to rotate it to get what I want and go from there. Now, if I have that and I've done that, I'm going to find in browser, and because I'm a crazy guy who likes things constrained, I'll look at my constraints. I constrain that. This is the best way to constrain for this rotation. And if you've taken the course, I show this, and we spend time on this. And I know my XY plane because I follow the substation modeling strategy. I'm always grabbing and constraining to the assembly and not to parts within the assembly. You want to do that with arrays or patterns, and you want to do that with constraints like this. So I want to constrain to that. I think I like that, or maybe I want it 180 degrees, but I'll leave it at that. So now I've got that placed exactly the way I want. So you can see how what the tools are that we can use and manipulate. So you can see we got that tool in here, and I also have a union in there as well. But further, I want to go a little bit further with playing around with these tools. And to do this, by the way, is you're combining the work geometry that is required. So for that bus piece, we want this work geometry, but we also want this work, we also want this work geometry. So we're adding the terminal work geometry in the bus geometry so that we can use those tools whichever way we want. Further, let's come out here and look over here. So here is what I've done recently. I've had a customer ask me about this, is that they don't always use a spacer. Sometimes they use a connector for a spacer. So I'm going to delete this stuff. I think I can delete it with this. Let's delete the cable because we got the delete cable tool, and we're going to delete this guy, and we're going to delete this guy. So I got the spacer in there, and this other company seems to use the spacer, and then they attach what they call an angled fitting for a tap. Now I don't have it in here, but I'm going to browse, and I'm going to browse the tap. So here's my browse the tap. I'm going to come in here. I'm going to look for my fittings. And I've called it something specifically with tap in the back, just to remind me what it is. But in here, I'm going to grab this tap. It's not really a tap, it's a fitting. Open it, and I'm going to stick it in here. And then now I can rotate it. I should be able to rotate what I want and get it in the orientation I want. I can move it, offset it, do whatever. I can ground it. And now I have a fitting in there that I can add another fitting to it. Oops, sorry, wrong one. Let's grab this EVH. Don't like it there. See if we can rotate it. And now I'm making my fitting that a customer wanted. So I'm going to just pick two fittings and stick that in there. So now I'm doing multiple things with different things. So for this guy here, what I had to do to get that to work is that I've added the normal cables tools that we use from the work geometry here, but then I added these a couple of tap points in there so that I can add these 2 tap points, and then I can use it as a tap as well. So I'm using multiple things here. So let's go over to the, let's see, what do we have? Below grade tools. We want to look at what we can do in the below grade tools, and we'll add some trench. So let's close this bay off. And if you follow the substation modeling strategy and you have these smaller assemblies that you can work with, it's a lot easier when you have 20,000 parts and thousands of items in a model to find things. So let's go into the underground. Here's my trench. Let's open the trench. We're going to place some trench in here. Now this first trench I placed using the trench from sketch tool. And that's a typical method, and that's typically what we do in a class. But what we want to do is show that we can add these other trench pieces. So let's come in here. We'll zoom in here. And we'll just add another straight here. And what I need to do is get onto that work point. So we come into the document here. There's a whole section on trench. We talk about what you need in trench. So we need these work points to do what I'm doing now. And we need of course, the UCS points. So this is in the document, and you can read it in there. So I'm going to add these trench guys. And away I go. I'm just going to flat trench wherever I need it. Further, I can add my transition piece in here. I'm picking that point. I have to have that point showing to get this to work. And then I can add a little light traffic piece, and away I go. Now, because we're only feeding from one end to the other end, for me to put another light transition piece in here, it's not going to do the way I want it. So you have to manually put the last one in to get it in because it's going down instead of up, because we want to come down to it and then come up to the next one. So in this case, I would have to manually manipulate this to get to what I want. Again, if I was to put in a cover, and I hit the button here, I'm putting in the covers. Now the covers, because of the way they are, we want to array them as many as what we need, maybe place it where we want it to place it exactly. We can find it in browser. Find that cover, and we can look at our joints. We look at our points here, and maybe we can offset it by a number, right? Well, not that one. That would be awful. All right, we could offset it, whatever. But if you're going to pattern in this stuff, and I know some people said patterning isn't efficient, but it is efficient if you pattern based on the assembly work features. So if I were to pattern this and I wanted to pattern that, I would base it on, looks like x-axis, and 36, just to see it. You know, you base it on the assembly one, and the efficiency is there. It will pattern that quickly, and you won't have problems. If something disappears, it won't break that connection because it's part of the assembly. So that's placing some trench items. Now, I only wanted to talk to about 40 minutes, and I'm hit 40 minutes already. So I'm probably talking a bit too much, but I'm going to continue with the conduits. So if we come into the underground again, and we open up the conduit, because again, we're following the substation modeling strategy, and we can see our conduit in here. And there's many ways to run conduit, but I wanted to show you running pieces. So this is typically what you'd have for underground, but the pieces I want to run are above ground. And again, substation modeling strategy, we put things in islands, and here's my transformer island. And in an island, we add as much pieces to it as possible. And you can see here that I've added some conduit in here. The method I used the below grade tool, grabbed an elbow, and put it on there. All right. Now when it puts it on, it doesn't know what direction you want to go. So I add my favorite constraint, the angle constraint. So come over here, constrain, put the angle on. Let's find this in the browser. So let's come in here, boom, 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 this guy. We're going to constrain that with an angle. And what we're going to constrain it to, not the foundation, not to the something else, but we're going to constrain it to a work plane of the assembly. And that way, it's the most efficient method of putting that in. The work plane's always there. It's not going to be deleted. And the software does not have to read the part to find out where that face is and slow down your regeneration of your model. So that's the most efficient way. So this is how this is put in, right? I followed through with all the below grade tools. I can add straight lengths. I can add variable length part. I'm going to stick that on here. It's just going to continue, and maybe I want 33 inches. I need to put inches on it, otherwise I might get centimeters or some other horrible unit. And I put it on there. So that's the way this was made. So now we've made this, we're coming down, we're following. And like the trench, it does the same type of thing, is that it goes end to start. So if we look at the conduit pieces required and what work geometry is required, we look at the end point and the start point, and that's what it's looking for, end point, start point, and it just molds it along there. So let's come over all the way around, and here we got some stuff here. And here I was playing around with this before I started this. Let's delete that guy and delete that guy. So this is really how it's going. I got a bell end, and now I need to come up with a coupling to finish it. And that's typical in real life. That's what we'd have to do. So I can add this coupling here, and remember what the coupling does. It's going to put it here. But I can also, let's go back into the assembly. And what did we say about the trench one? What does the trench one do? Let's zoom in all the way. Work point mate to UCS constraint set. So that's how that's placed in. Oh, no, that's trench item. Work plane mate to point mate. So that's how that's placed in there. So if I use this tool, it's placing in work plane mate. So let's come in, find that in the browser, and we can look at the constraints there. You can look at that mate to the work plane. That big work plane's the elbow work plane. And typically you want to make your work planes auto resize, and that way you can see them easily. Turn off the visibility, of course, but auto resize. And here's the other mate to the point. So that's how that one's placed in. But sometimes you may not want that, because we can do other things. We can also come to, believe it or not, our above grade tools and put a piece of conduit in. Is one better than the other? Depends on what you're actually doing, because I can put that right on that surface, and it's actually centered a little bit more. The other one's a little bit offset, maybe 1/8 of an inch or something like that. It's how particular you're going to be and what that part needs. I'm only showing a conduit coupling. It could be something a little more important than that. So that's how that's placed in. So if we come in here, I'm going to put that coupling. It's going to look for a circular face, and there it goes. So there it's put on. Again, if I find that in the browser and I want to shift it, I can always shift it using the mate. So there's my mate. Let's shift it. Oh, 12 inches. Maybe it's this mate. Oh, I can't shift it because it's a mate to a point and mate to a face. So it can't be shifted. So if I put the other one on, let's see what happens. If I put the other one on, I haven't done this to note it, but this is where we're learning. Find in browser. There, that mate and that mate. So let's see if I move this mate. Oh, it doesn't like it. So maybe I can't shift either. Don't want that shift. Okay, so they're very similar. One puts it a little bit differently, not a lot, but two different ways of doing it. I would tend to stick with the below grade tools offhand just because that's where it is, but I want to show you that there's other options too. So that's there again. We have put everything I could on this island, so that island's ready to go. If I have a vertical change, everything's going to move with it. And that's what I want with the substation modeling strategy. Of course, this is a phantom assembly. I'm going to save that. And with that, I'm pretty well done. What I want to do is leave some time for Q&A. If you guys got questions, don't raise your hand because I'm not going to see you. I ate all the pizza here, so I can't hand out any pizzas. So go ahead if you guys got a question. Raise your hand. There's a question tool here. Phone me. Go in the chat line, however you want to do it. So I'm going to leave it at that. It's still being recorded. And the recording, I hope to post it on the consortium.